Hello everyone, welcome to the discussion video of week 2. So in this video we'll be discussing the fourth problem, and the problem says that you have a function from the closed and bounded interval a comma b to r, the real numbers, and the function is continuous on this closed and bounded interval, and it is differentiable on the open interval a comma b. And if there exists a point c in open ab such that you have this f of b minus f of c by f of c minus f of a is lesser than 0, then you have to prove that there exists a point xi in open AB such that f dash xi is equals to 0. The core of the problem is this portion, and let's analyze that to solve the problem. So now, since that ratio is strictly lesser than 0, so that means if the numerator is positive, then the denominator has to be negative, and if the numerator is negative, the denominator has to be positive. So there are two cases. So let's take case 1 where our denominator is positive, and so we have f of b minus f of c is greater than 0, and it cannot be equals to 0 because it's strictly lesser than 0. And so we have f of b is strictly greater than f of c, and since the denominator has to be lesser than 0, so let's take that, and this implies that f of a is strictly greater than f of c. Now if you notice that f is a continuous function on the closed and bounded interval ab, and so f will attain its absolute maximum and absolute minimum within that interval. Now in case 1, let's consider that xi is a point inside AB for which the function f attains its absolute minimum. And now why did I write xi is strictly inside the open interval AB and cannot be on the boundary? So xi cannot be equals to A, or xi cannot be equals to B, the boundary points, because you see that since I'm working with the absolute minimum, and f of b and f of a, they are strictly greater than f of c, and so the minimum has to be lesser than or equals to f of c, and so the minimum doesn't occur on the boundary. Now coming to case 2, what we'll be having is that we'll be taking the numerator to be negative, and so we have f of b minus f of c is negative, which implies that f of b is lesser than f of c, and this implies that our denominator has to be a positive quantity. So we have f of c minus f of a to be greater than 0, and this implies that f of c is greater than f of a. So in this case you see that f of c, the point inside the interval AB, is strictly greater than the values at the boundary. So now here we can use the maximum. So let xi be a point inside AB for which the function f attains its absolute maximum. And again in this case xi won't be equals to a, or xi won't be equals to b, the boundary points, because I'm working with the absolute maximum. And as you can see that f of b and f of a, they are strictly lesser than f of c, and the absolute maximum can be greater than or equals to f of c. We have that in both the case, since it's attaining absolute maximum or absolute minimum, what we can say is that f dash xi has to be equals to 0 for some point xi inside the interval ab.